The privileges needed to create and execute functions are the same as for procedures. Even though it says procedure in these privileges, they are for both procedures and functions. In the code snippet, we are giving these privileges to the demo user. You need create procedure privilege to create procedure or a function in your own schema, create any procedure to create a function or a procedure in any schema, alter any procedure to alter a function or procedure in any schema, and execute privilege to execute a function or procedure created by someone else. Let us examine the simplest way to create a function. It starts with the create or replace function. Or replace keyword is optional, and just like for creating procedures, if you specify it, it will overwrite a previous declaration, and if there is none, it will simply create a new function. If you do not use it and you have an existing function, Oracle will error out with an object name already exists error, requiring you to drop the existing function first and then creating it. Using or replace is very convenient, and I prefer to use it. That is followed by the schema.function name. You need to specify the schema only if you are creating a function in another schema. Otherwise, you need not specify it and it will default to your current schema. Next is the return clause. A function, unlike a procedure, has to return a value. It can be a simple data type like varchar2 or date, or a more complex one like a record or a collection type. Next is the declaration section. Unlike the anonymous block, there is no explicit declare keyword. You can declare variables, cursors, exceptions, etc. over here. In order to find out more about these, please refer back to part 1 of Oracle PL SQL Fundamentals course. Next is the begin keyword, which marks the end of declaration section and the beginning of the execution section. Here, you write the business logic. You return back the data type which the function declaration states it will return back. Next is the optional exception section where you catch any exceptions. Notice that if you are handling the exceptions and not raising them further using the raise keyword, then you need to return an appropriate value from the exception handler too. If you miss doing that, the function will still get compiled with no errors, and there would be no problem if the function completes normally and returns back a value. But if an exception is raised and handled by the exception handler and there is no raise keyword as well as no value is returned over there, then Oracle will raise a runtime exception of aura-6503 with a message function returned without a value. This is the simplest form of defining a function. We will take a look at how to pass parameters to functions and procedures in the next module. We will also look at keywords like deterministic and parallel enable, which can be used with functions in a later module when we talk about calling a function from a SQL statement. Let us take a look at a simple function example. Here is a function which returns the count of employees in the IT department. We start the declaration by stating create or replace function getEmpCount. GetEmpCount is the name of the function. Then we say return number, indicating that this function is supposed to return a number followed by the as keyword. Next, we declare a cursor to fetch the department ID for department name IT. We declare it as cursor cur get dptid is select department ID from departments where department name is IT. We declare ldptid to fetch the results of the cursor and make it the type departments.dptid %type. We declare lcount to hold the result of employee count for the department. Next, we end the declaration section and begin the execution section with the begin keyword. First, we open the cursor cur get dptid. We fetch the results of the cursor into ldptid. Then we close the cursor. After having obtained the department ID, we now get the count of employees by issuing select count star into lcount from employees, where empdptid is equal to the ldptid which we just fetched. We finally return the result as return lcount, which is a number type which the function is expected to return. Next, we have an exception handler section with the when others exception handler to catch any unexpected errors. Here, we output the SQL error message and the error stack using the dbms utility .formatError function. We then use the raise keyword to raise the error to the calling client. If we did not have the raise keyword and an error was raised, Oracle would have given a runtime exception of aura -6503 with the message function returned without a value.